geobyte.
Dear students, let us take the another question. It is asked like this. Try to read it clearly. A small steel ball is dropped into a long cylinder containing glycerin. That means small steel ball is immersed in the glycerin liquid. Which one of the following is the correct representation of the velocity time graph for the transit of the ball? You are asked to decide the correct velocity versus time graph. Okay. For this, let us take a let us take a ball. Let us take a ball. This is the ball. Let rho b is the density of the ball and r be the radius of the ball. Radius of the ball. This ball is immersed in the glycerin liquid. This ball is immersed or placed in the glycerin liquid. This is the glycerin liquid. This is a glycerin liquid. Let me write it. Glycerin liquid. Let the glycerin liquid density, the liquid density is royal. Royal. Right? Now, once the ball is immersed or submerged in the glycerin, buoyant force is acting or buoyancy force is acting vertically upwards while the self weight of the ball is acting vertically downwards. Similarly, the viscous force also acting vertically upwards because the ball is moving down. Since the ball is moving down, the viscous force is acting vertically downwards. Then what is the net force? Here, the net force on the ball equal to mg. Mg is more than sum of the Fb and Fv because the ball is moving down minus the buoyancy force minus viscous force. This net force must be equal to mass times the acceleration according to Newton's second law. Okay. But as you know, mass equal to what? Mass equal to, since density rho equal to mass by volume, from this mass equal to density multiplied by volume. Volume of the sphere equal to 4 by third pi r cube. Okay. Now mg in the place of m, I can write density of the ball into volume of the ball multiplied by g minus buoyant force equal to mass of the liquid mass of the liquid multiplied by g minus the viscous force equal to 6 pi mu rv. R is the radius of the ball. Rv, it is equal to mass times the acceleration is dv by dt. Listen carefully, very very important. So here density of the ball into 4 by third pi r cube into g minus here mass of the liquid equal to what? Mass of the liquid, density of the liquid 4 by third pi r cube, that is the volume of the what liquid displaced. Volume of the liquid displaced is nothing but volume of the ball only multiplied by g minus 6 pi mu or v, where mu is the coefficient of viscosity, into m into dv by dt. dv by dt. So it can be also written as dv by, listen carefully, dv by dt equal to density of the ball into 4 by 3m, means I am dividing with mass on both sides, pi r cube g minus rho L, density of the liquid, 4 by 3 times the mass of the system, right? Pi r cube g minus 6 pi mu r by mass into v. Okay. Now this dv by dt I am writing as k1. One more step, 1 minute. It can be also written like this. It can be also written. Let me write the 4 by 3m pi r cube g outside, density of the ball minus density of the liquid, that is glycerin liquid, minus 6 pi mu r by m into v. It can be written as k1 minus k2 into v, where k1 equal to 4 by 3m pi r cube g into density of the ball minus density of the liquid, and k2 equal to 6 pi mu r by mass. Understood clearly? Yes. Now let's take another slide. dv by dt. You got dv by dt equal to k1 minus k2 into v. Correct? k1 minus k2 into v. Okay. From this, I can also write dv by k1 minus k2 into v equal to dt. Now upon integration, so it is 0 to v dv by k1 minus k2 into v is equal to integral 0 to t dt. Right? Simplify this part. Simplify this part. It will give ln k1 minus k2 v, apply the limits from 0 to v, minus 1 by k2 is equal to t, is equal to t. That can be also written as ln k1 minus k2 into v divided by k1 into minus 1 by k2 is equal to t, or ln k1 minus k2 v by k1 is equal to minus k2 into t, or k1 minus k2 into v by k1 is equal to e power minus k2t, k1 minus k2v equal to k1 e power minus k2t, or k2 into v equal to k1 minus k1 e power minus k2 into t. Let me write the k1 outside, 1 minus e power minus k2 into v. From this, velocity v equal to k1 by k2 into 1 minus e power minus k2 into t. So this is the relation between the velocity and time. Here k1 and k2 are constants. This is the velocity time relation. Here the velocity v is function of exponential power t. Therefore velocity and time are exponentially varying. Therefore among the given options, look at the curve which is maintaining the exponential variation. Option B, it is the velocity versus time graph varying exponentially. Therefore you can select the option B. Understood clearly? Yes. Then let's take the another question. It is asking like this. It is asking like this. The displacement and the increase in velocity of a moving particle in the time interval of t to t plus 1 second. The time interval from t to t plus 1 second means 1 second only, or 125 meters and 50 meters means distance traveled distance traveled in the time interval in the time interval from t second to t plus 1 second, that is 1 second is 125 meters. Acceleration in 1 second. uh, Increase in velocity, not acceleration. Increase in velocity means let u equal to initial velocity, initial velocity, v equal to final velocity, then what is the increase in velocity in 1 second? Increase in velocity in 1 second is v minus u. V minus u, that is equal to 50 meter per second. But what is the acceleration? Rate of change of velocity v minus u by t. V minus u is 50. Here time interval is 1. It is nothing but acceleration. 50 meter second inverse. That is the acceleration. Okay. Next. The distance traveled by the particle in t plus 2 seconds is. What the distance traveled by the particle in t plus 2 seconds. Right. So it is like this. First let us decide the initial velocity. Right. You know v equal to u plus 80, right? Now here the uh, u plus 80, v minus, already you got it acceleration, already you got the acceleration. Then distance traveled by the particle equal to s equal to ut plus half 80 square. The distance traveled in 1 second is how much? 125 meters. 125 is equal to u into, in 1 second means t equal to 1, half into acceleration is 50 into 1 square. From this you can decide the initial velocity. U plus 50 by 225. From this the initial velocity equal to 125 minus 25 is equal to 100 meter per second. Okay, that is the initial velocity. Now I am deciding the final velocity. Since v minus u equal to 50 meter per second, is it correct? Yes, v minus u equal to 50 meter per second. Then v equal to u plus 50. U is how much? 100. This is the u. 100 plus 50. It is equal to 150 meter per second. That's final velocity. Okay. Now distance traveled in the time interval, from t plus 1 second to t plus 2 seconds. That is nothing but 1 second. T plus 2 second minus t plus 1 second is 1 second only. S equal to ut, right? After 1 second, the velocity is becoming v now. Velocity is becoming v, means velocity of the particle at a time t plus 1 is v, vt plus half A t square. S equal to V. You got it 150 into time period 1 plus half into A 50 1 square. It is equal to 150 plus 25. It is equal to 175 meters. That is the distance traveled by the particle in the time interval from t plus 1 second to t plus 2 seconds. 175. The answer is 175 meters. I hope you understood. Understood or not? Yes.
Geobyte.